All right, so the female side. So now we're going to the female side of things. Female reproductive system, we're going to go through the overall anatomy and physiology. So as I started with the gametes for the male, I'll do the same for the female. We'll start with eggs or oocytes. And I don't mean to say, be biased and say that eggs are more important than sperm, but I say precious eggs because why?
We don't keep making them.
Right. Females don't keep making them, okay? Do we make as many? Do females make as many? No. I'll go through the numbers of that a little bit later, but roughly we have about 1 million at the time of birth. And it's a slow eventual loss every single month, every single year, losing them from that point forward. Males will make, remember I said 4,000 per heartbeat, if you do the math, the rough estimate, okay? They make trillions and trillions and trillions, okay? So there's a major difference right there in the number of the gametes. Also the size of the gametes is a big difference. Question?
Does that mean they go through 1 million periods?
We do not go through 1 million periods. Do the month of that. Do the math of that and look at the months. You have 12 months in a year. If the average woman cycles at a 28-day cycle, okay, and you menstrual cycle, you have from about the average age of 12 to the average age of 51. If someone wants to do the math, just do 51 minus 12, that's how many years, multiply it by 12, that's the number of menstrual periods. It's in the hundreds. It's in the hundreds. So, no. Yeah, Tatiana.
What about if you're on birth control?
That's an excellent question. We're going to do a whole lecture on just birth control and contraception. And I know a lot of you are on different types, as am I. So there's a lot of stuff to talk about there. If you're on contraception, you are not ovulating. You're still losing eggs. They're still dying. But you're not ovulating that one winning follicle in the egg. So you're cutting down the number of ovulations, but the eggs are still dying. Yes?
So if you start your period at an earlier age, you're going to be like infertile at an earlier age? Like would you start like menopause at an earlier age?
Nope.
So like starting the year, so like I was 10 years old when I started my period.
Yep.
So like that wouldn't affect like.
Nope.
when it
So
stops.
typically, the start and stop of the reproductive lifespan are not connected. There are genetic correlations and nutrition and environmental things that are rated, but a lot of genetics and height and weight and things in your family that you inherit when you start and when you stop. But those two things, if you start early, it doesn't mean you're going to enter menopause early. Absolutely not. Those two things are kind of disconnected. Okay, we'll talk, we have a whole lecture on that too. So we have a whole lecture on reproductive aging and the reproductive lifespan, going from menarche to menopause. So precious eggs, I'm not being female biased. I am telling you, biologically speaking, females have less, they have fewer, they don't have ogonial stem cells, we don't keep making them until we're 60, 70, 80, 90, and they're bigger, okay, they're larger in size because they are going to be responsible for getting the embryo growing, right, the growth of the new individual. They develop inside of follicles, so these are structures like this, like this, like this, going from small to big. They develop in these multicellular sacs or follicles. In biology, we call follicles just a sac. Okay? And they develop inside of these follicles, and these follicles are the ones that make the hormones. Okay? So they're the different types of cells that make the hormones in the female ovary. Follicle means multicellular sac. Females have all the eggs they're going to have before birth. They're halted in prophase until they get ovulated. So remember meiosis, prophase 1? Remember prophase 1? The tetrads line up, they sort of condense, they find each other, they do chiasmata, or crossing over, genetic recombination. So these eggs are halted there in the fetus of the girl before birth, okay? And that's where they're at. Some eggs are arrested in prophase 1 for 50 plus years. That means before birth in the fetus, just a few weeks into development, fetal development, about 12 weeks, they enter meiosis, and they stop. So now if that egg does not ovulate until I'm 50, because my mom entered menopause right around 52, 53, so that's probably where I'm going to enter. It's very genetically linked when you enter menopause. There's a lot of genetics are associated with that. I studied that actually. So that means that egg has been halted and waiting to resume meiosis and continue the division of meiosis and final maturation. It can be like that for 50 years. Eggs are lost throughout life and they're depleted at menopause. So every single month, every single year of a female's life, even before they are born, the eggs are dying. These follicles, these structures right here, here's a smaller one, here's a bigger one, here's the really teeny ones that are primordial, they're not yet really recruited and growing. The follicles themselves and the eggs themselves will die. they'll undergo atresia, and they'll be lost. So it's an eventual process of loss throughout the entire life until you hit menopause. We call this the finite reproductive window. That means females have a finite number of years that they are fertile and that they can conceive and have a baby, or we call it the reproductive lifespan. I've taken these images. This is one with fluorescently tagged and labeled eggs within the developing. There's little follicle cells that are starting to surround these. This is in the human adult ovary. I got it from a biopsy of a woman. She was about 35 years old. Really pretty pictures, though. I should show you some testes pictures. Some of the prettiest pictures in the human body are the ovary and the testes. Now, so they go, "Oh, what's that?" And I say, "Oh, that's sperm in the testes." And they're like, "Oh, wow, okay." And they go, "Oh my gosh, it looks like a galaxy or solar system." That's eggs in the human ovary. So they're really, really pretty the way they arrange and the way their architecture is. And this is what's going to give new life. So for me, it's just fascinating. This is why I've studied this for 20 plus years. So this is the female reproductive anatomy. The overall, and I'm sure most of you are familiar with the female reproductive anatomy, but we're just going to kind of go over the general part. Here is the uterus, here's the bladder. The bladder is anterior or more in front of the uterus, okay? The pubic bone, the pubis, and you can feel that in the mons pubis, right? Your pelvis comes together. That bone, that's kind of right connector bone right in the middle of the pelvis. Pubic symphysis, clitoris is right underneath ventral to that. And notice, and this varies in size. People think clitoris is really tiny. Some individuals, it's about 4 to 6 inches in length. And it has a body and it has sort of legs that are underneath the tissue itself. And we can only see a little part of it. Okay, so we'll get more to that later too. Here is the bladder, the urethra, so that is the pee hole. Okay, so I've had friends that are like, "We have 3 holes?" Yes, we have 3 holes. And then I saw Orange is the New Black, and there's a scene where the girl's like, "Oh my God, we have 3 holes." She never knew. Okay, so if you've never done any self-exploration or never read about that, yes, there's 3 holes. There is the urethra, or the external urethral opening. There's the vagina opening, or introitus, right here. And then there's the anus coming from the rectum. The large intestine is all up here. So the uterus has 2 arms that come off. One is missing because it's a sagittal view. The oviduct, or the fallopian tube, and the ovary. Okay? So those are all the major structures of the internal reproductive system of the female. Notice in the male, remember the male, the ejaculatory duct and the urethra coming from the bladder, they all went into the spongy urethra, right? They all end up, the urethra in the male is about 20 centimeters long. The urethra in the female is about 3 inches long, okay? That's another reason why females are more predisposed to things like UTIs and yeast infections and all that, right? Because there's a short little duct, so stuff can get in there easily. Male has a long 20 centimeters urethra, so quite a difference in the anatomy, okay? So reproductively, the anatomy is quite different. Here's the ovary. Here's the fimbria, or the little finger-like projections. No, these are not connected, okay? So the fimbria of the oviducts actually move with sort of the heartbeat and movements inside of the body and fluid, and they sweep over the ovaries. They are not connected. So people always draw this, and it looks like they're hanging onto the little almonds. Ovaries are the size of almonds, by the way. They're about exactly the size of almonds. Testes are the size of walnuts. Ovaries are the size of almonds. So the fimbria actually sweep, and they kind of move like this. So when the egg ovulates and ruptures from the ovary, it gets caught by the sticky fimbria that has cilia and sort of mucus, and it gets caught, and then it gets transported and moved into the opening of the oviduct, which is right here. Uterus is right here. It's got a muscular wall. It's got an internal endometrium lining the uterus. It's got a cervix. Here's the neck of the cervix. The internal os, or opening of the cervix, the cervical canal. The external os of the cervix. So this is like a plug, sort of, with a very narrow chamber going from vagina, which is almost like a cylindrical space, through the internal part of the cervix, or the opening of the uterus, and then here's the uterus. And then the vagina would go all the way down to the external urethral opening, all the openings in the reproductive system. If we cut through, we can see the inner part of the ovary right there, and the fimbria, and the fallopian tube. Okay, so there's a couple positions of the uterus. The normal or typical location of the uterus is antiflex. So it kind of flexes forward, goes forward over the bladder a little bit. Okay, so it's like this. Retroflex is kind of the abnormal or unusual position where it's kind of going back, pushing more towards the rectum and away from the top of the bladder. Okay? This could be relevant, positions of the uterus or congenital defects of the uterus. Sometimes individuals have half a uterus or two uteri or a bicorn uterus that's kind of split in two. Those are very rare. These are more common. This is the normal position. This is sort of the retroflex. This would come into play if someone was to get something like an IUD, an intrauterine device, which is a contraceptive little structure. Basically, it gets right